Okay, this is the last topic before we move on to circuits and capacitance. Equipotential lines. An equipotential line, or a surface, as we call it in 3 dimensions, which we won't deal with 3-dimensional equipotential surfaces, is a line where the potential is the same. So if you were in a lab, you had to draw equipotential lines. Same, or where it's constant. And along these lines, the change in potential is 0. That is delta V equals 0. And also the work required to move a charge along an equipotential line is also 0. Because if you remember, our potential is, our change in potential is energy per charge. So if this is unchanging, if that's 0, then that means that the change in energy is also 0, the energy required. I have a couple of rules regarding equipotential lines. First of all, the electric field is always perpendicular to the equipotential line. So if I have a positive charge here, and I put my positive test charge here, and I find that the force acts on it in that direction. And so the electric field then, in this case, for this charge, emanates outward radially. Similarly, the electric field here emanates inward radially for a negative charge. Remember, if I put my positive test charge here, it feels a force in that direction, so that's also the direction of the electric field. Now, the equipotential line is always perpendicular to the electric field. So they will look like this. A charge along this equipotential line will have the same energy. So a charge here will have the same energy as a charge here, or here, or here. And in fact, a charge can move along this equipotential line without any energy at all. So it can move freely. And then my equipotential line, I have equipotential lines that move outward. So these are just lines that we draw to represent where the potential is unchanging. Now, if we have 2 charges like this, a positive and a negative, and the equipotential lines are a little more complicated, but they're still perpendicular to the field lines. So they're going to look something like this. At each point, the field line, the equipotential line, is perpendicular to the field line. So it'll look something like that. Here I'll have an equipotential line that'll just go straight down the center. Something like that. And as I said, in that PhET simulation, you can play around with this, or if you're in a lab, you've already done that, and you've actually mapped out equipotential lines and electric fields. All right, let's try this quick test. You can try that on your own. And then the next thing to come is capacitors, which we'll pick up with in just a bit.